All right, Ariel, cheers. We are back. Pints with Ayre, 728. We missed a couple weeks. I missed a few weeks. You were gone, and I couldn't do Pints with Ayre without you, I guess. So
There you go.
so now we have to make up for it and do a couple episodes a week and catch up. And
Okay.
yeah,
Try.
but we had our birthdays, so maybe this is the birthday episode, and
Like that.
we had to get some real special brews this time. I picked up some Tequila Cerbus for us from Avery. This is like a unique limited batch. It was bottled March 17th, 2017. And it's a barrel aged series ale aged in Suerte tequila barrels. You had a little story about Suerte. I hadn't heard of that before.
Yeah. So Suerte, I believe, is actually a Boulder-based company, and my understanding is that they commission tequila made. It's actually called tequila, so it is actually made in Jalisco, Mexico. And so it's I don't have any personal connection to them. I know that I know some people who are connected with them, and so like some of our bike races and stuff, we get a lot of the podium prizes are often bottles of Suerte, so I see it around a lot. And it's actually it's in my top 5 list of favorite tequilas to get regularly at home. I really enjoy it. Anyway, yeah. So tequila barrels. Avery has they have regular barrel aged series. They've so if you go to their brewery, they have a whole barrel aging room, this huge room. They have racks and racks of barrels where they have all these projects where they do barrel aging, a special series, and they're always amazing. Often they're pretty strong. This one is surprisingly not. That's 7.35. But yeah, and they've done many sours over the years. I'm generally I generally like sours, just as long as they're not over the top. I've had plenty that are just way too sour, and so I like the kind of middle ground, either kind of light to middle ground, out of kind of like a wild ale or something like that can be really good. So Upslope has done some, and Avery's done a lot of them. So as long as they're not crazy sour, I like them a lot. This one's delicious.
Yeah, I typically really like a mezcal tequila because I like a smoky, peaty kind of flavor profile too. So this doesn't really have that, but it does. I don't know. I think the sour and the tequila barrel age complements each other rather well. It's a really cool concept. I like it a lot. But yeah, Avery does cans for their normal stuff, and then they'll do kind of these limited edition batches. I don't know if you can get them just anywhere. I think you have to go to
they're probably hard to find.
Yeah, these are a little more exclusive and hard to find, but if you can get your hands on a Tequila Cerbus, that is what we're drinking on for our birthday edition for Pints with Ayre. Yeah. And so you were out of town, you got a little time away from the office, and
I had quite a bit, a week and a half off, mostly off the grid, had very little cell service, so you guys weren't able to let me know of all the fires going on here, so came back to plenty to do, but
sure,
that's the way it goes.
Oh yeah. No, but now that you're refreshed, we can work faster and more efficiently and get things done.
Sure.
My turn next, though. Yeah, so I figured since you were gone and you're just kind of jumping back into it with us, and you've probably got a ton of stuff piled up that you need to catch up on, we could do something easy but fun still and talk about one of our favorite classic products, the V5 power amplifier and the V6 power amplifier, because they were kind of
very related kind of, siblings, and they share so much. So yeah.
Yeah, and from what I could tell, it looks like they kind of had the same kind of launch and life cycle as far as production too. So made sense for us to just kind of put them both together, and we're gonna talk V5 and V6.
Yeah. So yeah, I doubt people realize just how much of a turning point the V5 and the V6 kind of represent as far as our circuit evolution, because that was really it was the first products, particularly power amps, but in general, that we switched to primarily bipolar transistor based circuitry, and as well as switching to our whole kind of current mirror coupled input stage to output stage. And it's been an evolution on that same circuit ever since. And so it was the first time we did it. And so it was a fairly long development cycle because we had a lot to learn. I became quite a bit more involved. At that point, I was still in school at that point. And so to save costs or whatever, what we did, the first prototype boards we made, I actually made a little prototyping, essentially a teeny little CNC mill in our prototyping lab at my college. So I have one of those original ones here, and so it's it was just a raw panel of circuit board material, and then plug in the Gerber data into the controller software, and then you have to set up the height really carefully with this little generally a V bit to cut out more or less to remove the copper, because the circuit board is full copper on both sides, and so instead of etching like any production process normally is, this is actually milling it out. So it has a little V cutter bit that spins like 18,000 RPM. It goes removes copper to isolate traces and pads and such. And so on one side, like this, we actually have to remove a lot of copper. And so I made 2 boards, I believe, maybe 2.5. I think one failed at one point in the production process. And so I think each board took about 6 hours just on the cutting machine. That's what I did. I was pretty much sitting there staring at it the whole time, making sure the bit didn't break or make sure it was still going. Anyways, that was it was very time consuming, a very interesting process, but I don't think anybody had attempted this large of a board. You were talking, it's like probably 5 by 12 inches or so each board. So like normally we did as far as class project, we did like little boards that were like 1 by 1 inch or something.
Okay.
So this was a very large project for that particular process. And so there was that part of it, and then we started getting into prototyping and testing it, and it all worked pretty much out of the gate. And then I would say the one really interesting, the snag that we hit, that fortunately we found pretty quickly. So a lot of listening tests, Charlie had one of the prototypes at home in his basement listening room, and then how we realized that it was getting oddly hot, at least in his setup, and we had it at work, it wasn't. And so when you run into things like that, and we've run into this many times since, it's kind of a running joke that it's pretty much any new design, it's almost bound to oscillate somewhere somehow. And so that was what was happening, was that the output stage was oscillating, and so it gets a very high frequency, a few hundred or maybe on the order of a megahertz or 2 oscillation. So what that does is that then draws a lot of extra current, and it runs runs quite a bit hotter, and it'll still pass the audio signal and still make sound. It doesn't sound quite as good because it's not operating ideally because it has all this kind of parasitic load, it's parasitic signal that it is almost generating itself. And so this was the first time that we had encountered that and had to find a solution. Because all the previous amps had all been MOSFET based, and so they have very different characteristics, and they're less prone to this thing. So we found out, and there's very little published research on this that we could find. We searched and searched and searched, and so basically, when you're talking about a bipolar transistor in a emitter follower configuration, it is prone to susceptible to oscillation due to capacitive loads. And so we were we spent months tracking this down, figuring out what caused it, figuring out ways to combat it. Basically we developed a way to test it and figure out where it was prone to oscillate. So so I still use every new amplifier project. I have this kit of capacitors that I have the amplifier set up on the test bench running a certain square wave test wave, and then I'm watching the output with a oscilloscope, and we put a capacitor across the leads and see how that changes the shape of the square wave output, to see if it overshoots and rings and how much, or if it just breaks out into just all out oscillation. And this is actually a pretty well-known but not well documented, like I said. So many, if not most, power amplifier manufacturers deal with this by adding a Zobel network at the output. So it's almost right at the speaker output post. That felt wrong to us. It's because you've done all this work to make this really pure solid state amplifier circuit with zero feedback, with no capacitor coupling, yada yada. And then to add this Zobel network with an inductor and a capacitor, resistor, it's really just a really ugly solution, really hinder the final output. And so we worked really hard to try to understand the cause better and to find a more elegant and the correct solution, as opposed to just adding this band-aid at the output. And that's what we did. So we were able to compensate for that kind of parasitic feedback mechanism, and place a fix much further upstream that basically avoids that oscillation. So it's, there's a lot more to it. I don't want to divulge too much more of it, because it is, I think it's a really special solution to a very common problem that I think most manufacturers, again, just kind of gloss over, and they just throw a Zobel network at the output.
Could you explain what that is? Maybe for those of us who don't know, like myself, what a Zobel network is? I haven't heard of that before.
Well, so it's again, it's been so long since I've even looked at it, and so you're essentially putting a very large kind of inductor and a capacitor, so it basically swamps any potential capacitive load that you have on the ground. So typically, like that capacitive load, there's a speaker, but most often it's actually the speaker cable. And so there's certain cables that we ran into that that present more of a capacitive load, just based on their construction and their design. They have a certain capacitance per foot. And so if it's a really long cable, it's gonna exhibit some more more capacitance. And then there'll be a little bit presented by the speaker as well. But typically we found that it was more the cable itself, which was more the problem. And so the Zoll network is just there to kind of swamp anything and basically make anything the load and the cable presents negligible compared to what the Zobel was. So it's also essentially just a filter. That's all it is. And so, but any filter like that is absolutely going to have a negative effect on the sound quality.
Right.
It just invariably cannot do good. It will only do bad. And you can use better and better parts quality and try to tune it better, but you're never going to get to zero. So that was probably the biggest hurdles we found, and that has, doing that work and figuring out the cause and the solution. And we've even refined our solution over the last several years, two decades, more than 2 decades now. And so our current solution is even more elegant than it was in the V5. Because I learned, we've learned more since then. And so, part of this is due because of our bridge amplifier topology. The fact that it's balanced. The power supply coupling between the phases is essentially the key, one of the key factors to this phenomenon. And so there's things you have to be really careful about in the particularly in the circuit board layout, really, to help avoid that oscillation. So anyway, building product by hand, dealing with that for that oscillation compensation, those were huge deals. But then again, just that, this was again the first time we really went to a full bipolar, accepting the we still use the JFET input stage. That hasn't changed and never will. But everything beyond that is all bipolar based. Which makes it easier to match the parts, because we use MOSFETs and stuff. It becomes much more critical and much more difficult to measure and match devices. The bipolar transistors, certainly in certain date code batches, are more reliably similar and are much easier to handle without very laborious matching. Which is beneficial to the production process for sure. So V5 and the V6, the V5, obviously the stereo version. We did the V6 as kind of our first kind of dipping our toes in the home theater waters. And so the V6 was a up to 6-channel configurable amp. So each individual channel module was exactly the same for the V5 or V6, exact same transformers used. So you can just plug in however many you wanted in the V5, in the V6, I'm sorry. I saw somebody build one as a mono once. I think we only did one of those. There were a couple even built as just as stereo, just with that option to be, and that flexibility in the future to be able to add.
Right.
We built plenty as 3 channels, those as 5 channels, and quite a few as 6 channels. It's quite a beast. That the V6, it's still internally designed more or less as 3 stereo amplifiers in one. And so there are 3 transformers. So 1 transformer for essentially a pair of channels. So it's not like there was 1 transformer supplying all 6. There's basically 3 transformers. And so even if you built it as a 1 or 2 channel, it still had all 3, so that you could at any time plug in another channel or run. So even barely stuffed, it was still a beast and very heavy because most of the weight is in those transformers, and 3 very large transformers. And I'll say that they are mounted very far forward, so it's very front heavy.
Yeah,
it could be awkward to pick up. You had to know that the weight was very far forward, so you have to have your hands almost at the faceplate to lift the thing and actually have it be balanced.
or be careful pulling it out of a rack or something.
Yes.
Yeah, three transformers. That's
Yep.
it's pretty wild, because I mean, yeah, no compromise in that regard. All linear analog power supply. No lightweight switching home theater amps here.
Yeah. And I think it was probably the first time we did a trigger input. You see in the picture I said trigger in out. That just daisy chain there. So if you plug in there, it just parallels to the other port, so you could pass it on to some of the product. It didn't have an output per se, it just had the trigger in, and it was configurable, and in later revisions automatically detecting for pulse or level style triggering, 5 or 12 volt pulse or level. Yeah, and we also offer that pass through input connector, which again was just connected directly in parallel with the input XLR. So if you wanted to, let's say, bi-amp with multiple channels of the same amp, you could just have a really short jumper from one channel to the next. So you could just have one input signal, connect it to 1 or 2 more channels. So you could buy or tri-amp a set of speakers. So you could have a V6 fully loaded and essentially tri-amp some more some of the larger speakers that actually offer, 3 separate inputs for high, low, and mid.
Yeah, I know a lot of our customers that have these, they swear by them because they're just such a powerhouse between that monstrous transformer, the 16 output devices per channel. I know this thing is it's well regarded for being able to handle those hefty 2 ohm loads, and they pair really well with like some power hungry speakers. They can handle anything you throw at them. And there's actually, I think, 2 or 3 here right now, just for kind of a spa treatment, since we offer that sort of thing. I mean, they only have 2 notable electrolytic capacitors per channel, and that kind of makes recapping an older V5 pretty cost effective. So it's something that we kind of commonly get back, because it's not compared to our other amps, 2 caps per channel is pretty easy for us to do.
Yeah. And the other thing I'll say about this especially for a power amp, this is arguably one of our most reliable products ever. I've, over the last 20 years, can probably count on 2 hands the amount of failures we've had of this product. This is probably the most reliable product, perhaps the most reliable product that we've ever made, which I think is somewhat remarkable, considering it was our first foray into bipolar power amp. But
right,
it's yes, it's a fantastic product for that alone. But again, like it was a huge step as far as again, really the beginning of our current circuit topology evolution. And it's our circuit's only gotten more complicated from here. Again, we've basically taken this circuit and kept on kind of adding to it to make it more linear, to make it more this and that. And there's really a beauty to this one, just how simple it is and just how well it works. Many of the improvements we made to it, decrease the measured distortion a little bit, stuff like that. But this circuit is, I'm I'd love to find ways to kind of revisit this circuit for some much lower cost products to try and get really simple, super reliable circuit. It's really hard to beat.
Taking notes for the idea board.
Yeah. Yeah. No, they've been churning back in my mind for years.
Yeah, I mean, I know I've had at least one or two folks asking if we make or have plans to make any new multi-channel amps over the last year, but I don't think that the demand is as high. I like the modular approach like this. I think it makes a lot more sense when you're considering anything other than stereo.
Yeah. I don't have any firm plans for something like that right now. Yeah, like you said, just the demand for it, I haven't heard. I'm certainly not getting calls or hearing people really asking for that very much anymore. That whole, specifically for the home theater application. I'm certainly not haven't been hearing that. Yeah, I mean, the stereo amps, you can easily buy multiple stereo amps from us to do the same function. The other thing I noticed from that picture, that I think it was the first time we used the clamping post from Cardis. And again, I think it's probably the best speaker connector design ever. I'm pretty sure we've talked about that before, but I think this was the first part we used, and we started. I think we used it here first, and then I think we retrofitted it to the V1 in its last few years of production. But I believe we started using it here.
Speaking of Cardis, we had a fun visit from them this week.
Indeed, they were in town, and they came by the first time that they visited us here at this factory. It was great. We got to go out to lunch. We had a fantastic time.
Yeah, they came out for Red Rocks, for Portugal the Man, who I swore I had never heard of before, but once I looked up some of his music, I'm like, I've definitely heard this. So yeah, he's all over the place. I guess he or they or Portugal the Man is everywhere and right under my nose. And it looks like they do a really good Red Rock show. I think they're maybe from Oregon too. I think Josh and Angela are kind of some Portugal the Man super fans. I think they caught him in Oregon and then came out here, but yeah, it was like a Easter egg hunt for them because we have little Cardis goodies all over the place.
Oh yeah. And I think they probably found 10% of them. I mean, I didn't even realize once I kind of think about it, and I walk around like, oh yeah, here's this little trinket. Here's a coaster. I've got tons of coasters.
Yeah.
But yeah, we have the little glass and case glass etched things, and yeah, it's too numerous. So
yeah, we didn't even go all the way into the back of the building too. There was like at least 4 or 5 rooms they didn't even look in, but yeah, they just scratched the surface, so they'll have to come back.
Yep.
Yeah. Well, V5, V6, yeah, pretty epic amps. I mean, these things, they're gorgeous, they're elegant. I mean, I can tell how looking at the V5 side by side to like the V3, that you could tell the V5 was definitely kind of like a turning point for the company in general, like circuit wise, aesthetically,
I mean, and it was also obviously the first time I went to, we switched to internal heat sinks as opposed to externally exposed heat sinks, and there's many reasons for that. Again, as far as safe temperatures, sharp edges, a lot of that was really nice to make that internal, so they weren't accessible to the outside, and so you're actually able to let it run a little hotter of the actual heat sink temperature, which can be good for bias. and we also experienced, a lot of the external heat sinks. Again, just the aesthetics and the sharp edges, we got, cut up a lot almost on some of those heat sinks. And so it's definitely more comfortable to pick up. In the middle of the life cycle of V5 to 6 is actually when we, because up until in all previous products and beginning life cycle of these products, the external width was 18 inches, which is a pseudo standard. But especially with the V6 intended to be a bit more home theater friendly, that dimension is not rack friendly. And so in the middle, we actually made some changes to the core chassis and some of the other pieces and the faceplate to actually reduce that to 17 and I forget the number, 17 3/8 or something, sort of 5/8, so that it would actually fit more easily into some custom rack mounting shelves. So it actually fit. So from that product on, every product since has been that 17 and change width dimension to make sure that it's rack compatible. And so if you go look at some of our old backstock on some chassis parts, you'll see some notes that say it'll be like wow, return it. So like there was non-rack and rack compatible components. So we have some old stock of the original wider chassis and faceplate pieces. So I have some excess stock of that.
Huh, that's pretty cool. And then I see like input impedance on this is lower than what it is nowadays. Like it looks like 100 kilo ohm per phase.
Yes, 100K. Yeah, so that was still, so we so prior to this we had the V3 and then the V1, and the V3 was originally pretty low, 100 at a 10K, 20K. I know one of the original upgrades was to increase that. It might have only been a 20K. The V1 quickly was 100K input impedance. No, the original release might have been lower, but I think it might have been 100K from the start. And this was 100K. Yeah, we didn't move to 100K input impedance until I think the KXR.
Oh, you mean 1 mega?
I'm sorry. Yes, 1 mega.
Yeah.
Yeah. I think the KXR is where we moved to 1 mega input impedance. Well, I'm sorry, MXR. It would have been MXR because we did the MXR first.
Yeah, got it.
And then we tried to match that in the KXR, and that had its whole host of consequences in the KXR design, but that was that we had to overcome because of that 1 mega impedance. But for another day. Yeah, if I remember correctly, MXR was the first 1 mega impedance.
Just because I'm cheating and I'm using the web page for the V5, I see this listed as a bullet point. It says sophisticated DC protection circuit. Was there something new that we introduced for the V5 for that, or?
No, that was virtually the same as we introduced in the V1. Has the same and at the same, and that really hasn't changed significantly ever since. We use the same discrete DC detection circuit, so it detects basically absolute DC, so it doesn't matter if it's negative or positive. And we look at each phase individually. We're not even looking differential. We're looking at if any individual phase is plus or minus 2 volts from the from signal ground. And so we started that in the V1. The V3 is the only power amp product that did not have any DC detection. But V1 had that.
Nice. Pretty cool. No, I love it. The few that have come in over the last year have been just kind of a pleasure to behold, because they're again, they're big, but they're not like the lack of external heat sinks make them just much more approachable. You know, it's like
yeah, they're pretty elegant. Yep.
Yeah,
they're rock solid. Again, one of the most reliable products we ever made. Really, yeah.
Well, I don't know if I've got any other questions on the V5, unless you got some more fun stories that I can jog your memory with. Let's flashing some pictures at you.
Boy, no, yeah. Again, just, you know, it was really kind of that was again the turning point in so many factors. You know, again, the circuit topology, chassis design as far as internal heat sinks, and then with the vents with the screen glued into the into the top cover. Binding post is all new to us. It was the first time we used those. We had some custom RCAs made for us. I think that was the first time we used those as well. Started using those in a lot of products since. Yeah, it was that was, you know, in so many ways a big turning point for the company. You know, at least certainly in the power amp side. You know, you know, the D1, which we already talked about, again was arguably a much bigger turning point, but in kind of different ways. But
right,
so as far as the core analog circuitry and the kind of really power amp side, this was again, yeah, a massive shift for us. Oh yeah, and this was, let's see, this is also the first time we used EI transformers. Everything up to this point had used toroids. And this was our first shift to EI transformers, custom made by Mercury Magnetics. And so
pretty big one.
Yeah, so that's also another good one, which we a couple years now, but we did a whole episode on transformers. We talked to Jim White, discuss some of the benefits and compromises between toroids and EI, and why we prefer EI transformers. So
yeah,
go find that episode if you want to revisit that topic. I don't want to.
If I can remember to put it in the description after this video, after the Tequila Cerbus,
sure, yeah.
I will do so.
Yeah. Yeah. So again, like all of our products, we, you know, over the years, we developed a couple different upgrades for this product. So this was originally the V5, became the V5X, the V5xe. We had, you know, again, that was quite common. Many of those upgrades were power supply related, again, refinements to either to the regulation or to filtering, but quite often power supply related. So that's what a lot of this was. So even if you have a really old one, we still offer those upgrades.
Yeah, I mean, as far as the records I have show, it looks like the last update was done in 2012. Initial production was May of 2001. I don't know when we discontinued it, but yeah, we still offer all available upgrades and revisions to this product. So whatever version you have, if you want to get it to the most current and do a little update and refresh to the caps while you're at it, we would be happy to do so. We usually have those parts here.
Yep. Indeed.
Yeah. V5. All right, Ariel. Well, I am all out of my Tequila Cerbus, and I think I'm out of amplifier questions. But this was a good one. Welcome back. Happy birthday. All that good stuff.
Cheers.
Oh man, see, it's so good. You haven't even finished it. It's too strong. It's a sleeper. It's a sleeper beer.
Yeah, it is bordering on being too sour. It isn't too sour, but it's just getting there.
Yeah. Well, we'll have to do some more of the special edition
I
so
would
that
love
we
to.
can
Yeah.
culture our airheads.
Yeah, we could
out
probably
there.
spend an entire year just going through their library of barrel-aged beers.
Yeah, for sure. Well, we're gonna have to. We got.
Okay.
I've lost track of how many we've done so far, but I think we've still got something like, I don't know, less than 20. We've got less than 20 Avery episodes, Avery themed beer episodes left, I think, so we can hit our 30 beers for 30 years for both of us.
Okay. Yeah.
All right. Cheers to our airheads. Cheers to you, airhead in chief. Thank you for your stories and your wisdom on the V5 and the V6. Products number 6 and 7.
Yep.
All right. See you guys next time. And gals, have a great weekend.
Cheers.
Cheers.